Right, so question 1 of the 2018 Edexcel A-level paper 1. Given that theta is small and is measured in radians, use the small angle approximations to find an approximate value of 1 minus cos 4 theta over 2 theta sine 3 theta. So the small angle approximations are found in the formula booklet and are as follow: cos theta equals 1 minus theta squared over 2, and sine theta is equal to theta. So we can rewrite this as 1 minus 4 theta all squared over 2 over 2 theta times 3 theta. That can be written same as 1 minus 1, since it's times the bracket, then that would become a plus there, so it'd just be 4 theta all squared over 2 over 6 theta squared. This can then be written as 16 theta squared over 2 over 6 theta squared. That's the same as writing 8 theta squared over 6 theta squared. The theta squareds cancel out, so it's 8 over 6, and that's the same as 4 over 3, and that is the answer. Okay, so moving on to question 2. Question 2, it has a curve C as equation y equals x squared minus 2x minus 24 root x, and x has to be greater than 0. A part 1, find dy by dx. So that's quite simple. So times the power, subtract 1 from the power, so 2x minus 2, and then so negative 24 root x can be written as minus 24 x to the half. So times by the power, minus 1, we get minus 12 x to the negative half. And that's part 1. Part 2 is from the second derivative. So do the exact same thing. So we get 2, that one goes, and we get positive 6x negative 3 over 2. Part B, by the way, I love Ermac a lot. Find the stationary point. That means you need to, when x is equal to 4, so you use the dy by dx and just put 4 into the equation. So 2 times 4 minus 2 minus 12 times 4 to the negative half, and it should be equal to 0. And so therefore it's a stationary point. And for part C, to determine question C, the nature of a stationary point, we need to put x is equal to 4 into the second derivative. So the second derivative is 2 plus 6x to the power of negative 3 over 2. So 2 plus 6 times 4 to the power of 3 over 2. And that will equal, if you put it in your calculator, 11 over 4. So to determine the nature, we need to, so 11 over 4 is greater than 0. So if it's greater than 0, it is a minimum point. So therefore, minimum point. And that is question 2 complete. So doing question 3, it is a radians question, so make sure your calculator is in radians mode. So we have figure 1 here. The angle AOB is pi radians, so we don't know the exact angle. The area of the sector AOB is 11 centimeters squared. Given that the perimeter of the sector is 4 times the length of the arc AB, find the exact value of R. So the area of a sector is the same. Well, the equation of it is half R squared theta. So that is equal to 11. So I'll leave that for later, just write down. And so this bit AB is the same, or the equation is r theta. So we want to find the perimeter. So the perimeter would be r plus AB, which is r theta, like we just figured. So it's the same as 2r plus r theta is equal to the perimeter. But the perimeter is 4 times AB, so it's 4AB. And AB is r theta, so it's 4 r theta. So we can make this, so 2 equals 3r theta. We can divide 3r, so we have 2r over 3r is equal to theta, and the r's cancel, so theta is equal to 2 over 3. We still need to find the value of r, so if we put theta, which is 2 over 3, into the area equation, we get half r squared times 2 over 3 is equal to 11. So if we times 2 to get rid of the half, we get 2 over 3 r squared is equal to 22. And that goes, and then if you divide 2 over 3, you will get 33 is equal to r squared. So r is equal to root 33. And that is question 3 done. Okay, so for question 4, there's two curves, y equals x and y is equal to 2 ln a minus x. For part A, we need to show, and x is equal to alpha, and we need to show that 3 is between, alpha is between 3 and 4. So, when we do that, is we first make the two lines equal each other. So, since they're both y, so we have x is equal to 2 ln 8 minus x. Then we make it equal 0. So 2 ln 8 minus x is equal to 0. So then we let x equal 3 for the 3 there. So 0 is equal to 2 ln 8 minus x, 8 minus x, and x is 3, so 8 minus 3, which is 5. Put that in the calculator. You will get 0.22. Then we let x equal 4. So we get 2 ln 8 minus 4 minus 4. And that's equal to negative 1.23. As we can see, there is a change of sign. So then you can write, due to change of sign, 3 is between, alpha is between 3 and 4. So for part B, using the graph and starting with x1 equals 4, determine whether or not this iteration formula can be used to find an approximation for alpha, justifying your answer. So to do this question, starting from x1 equals 4, so start from this point, you draw up to the curve, and you go close to the next curve, towards the next curve, and then towards the next curve, and towards the next curve, and towards the next curve. And since it's getting closer to the intersection point, it will be suitable, so you can write B. Yes, it can be used since the diagram shows the cobweb spiraling inwards. Right, and that is part 4, question 4 done. So, moving on to question 5. Given that y is equal to 3 sine theta, 2 sine theta plus 2 cos theta, show that dy by d theta is equal to a over 1 plus sine 2 theta, where a is a rational constant to be found. So, since y is in the form of u over v, we will use the quotient rule. So, u is equal to 3 sine theta, u dash is equal to 3 cos theta, v is equal to 2 sine theta plus 2 cos theta, v dash is equal to 2 cos theta minus 2 sine theta. So, we times them, we'll get 3 cos theta times 2 sine theta plus 2 cos theta. Plus, minus 3 sine theta, 2 cos theta minus 2 sine theta over v squared, which is 2 sine theta plus 2 cos theta all squared. So if we just expand these brackets, we get 6 cos theta sine theta plus 6 cos squared theta. That's all minused by 6 sine theta, 6 sine theta plus minus 6 sine, son of a bitch. Minus 6 sine theta cos theta plus 6 sine squared theta, right, over 4 sine squared theta plus 4 sine theta cos theta plus another one of those plus 4 cos squared theta. Fucking hell. Right, this is all equal to, so this and this get cancelled. So it just leaves the top with 6 cos squared theta plus 6 sine squared theta over 4 sine squared theta plus 4 cos squared theta plus 8 sine theta cos theta. Right. 8 sine theta cos theta is the same as 4 sine 2 theta because the rule. And another rule is cos squared theta plus sine squared theta is equal to 1. And since we've got 6 and a 4, and these are also those, we'll have 6 over 4 sorry, fucking hell, 4 plus 4 sine 2 theta, and we can take the 4 out since we need it to look like 1 over sine 2 theta. So 6 over 4 times 1 plus sine 2 theta. Since we want a at the top, we put it as 6 over 4 over 1 plus sine 2 theta. And the question is complete. Okay, so beginning question 6, the circle C has center 7, 5. The line L with equation y is equal to 2x plus 1 is a tangent to C at point P, as shown in figure 3. Show that an equation of the line PA is 2y plus x equals 17. So since the line L is y equals 2x plus 1 and PA is parallel to that, the gradient of PA would be the negative reciprocal, which is negative half. So using the equation of the line mx minus x1 equals y minus y1, you can write this as negative half times x minus 7, since that is the gradient, the x, equals y minus 5, since that's the y value. So then we can expand out this bracket, so we get negative x over 2 plus 7 over 2 is equal to y minus 5. If we times everything by 2, we get minus x plus 7 is equal to 2y minus 10. And then this rearranges to 2y plus x is equal to 17. And that is part A done. For part B, find the equation for C, so for the circle. So we have two different lines, so we need to do it simultaneously. So we have 2y plus x is equal to 17. And to put it into y equals, it will be y is equal to 17 minus x over 2. And the other equation is y is equal to 2x plus 1. So we make these equal each other. So 2x plus 1 is equal to 17 minus x over 2 times by 2, so 4x plus 2 is equal to 17 minus x. So this can be rearranged to have 5x is equal to 15, so then x is equal to 3. Then if we put the x value into the y equals 2x plus 1, y is equal to 2 times 3 plus 1 is equal to 7. So point P is at 3, 7. And so that's the center, but we need to find, I mean, that's not the center, that's the P value to find the radius. And so to find the radius, we need to do the difference of the x values, all square rooted. So if you look up, 7, 5, and 3. So we get 7 minus 3 squared plus, now the difference between the y values, 7 and 5. So 7 minus 5 squared. Put that in your calculator, you get root 20. So then the equation for C is x minus 7 squared plus y minus 5 squared is equal to 20, since r squared in this case. Okay, now for part C, we need to find the value constant k. So if we write down what was given in the question, y is equal to 2x plus k, we can see that 2x is parallel to the negative half, or it's the same as the original line here. So we can see that there is a second line, we could call it L2. And since the circle, since it's a radius away, we can see that, so point P was at 3, 7, and point A was at 7, 5. So we can see that it goes up by 4 and down by 2. So that means this point would be 11, 3. So we can use that in this equation. So 3 is equal to 2 times 11 plus k. So 3 equals 22 plus k. So then k is equal to negative 19. And that is question 6 done. Right, so for question 7, show that the integral with limits 3k and k 2 over 3x minus k dx is independent of k. So to make it independent of k, we need to get rid of the k entirely. So what we'll do is 3k, k, 2 over 3x minus k dx. So the easiest way to integrate this is by taking out 2 over 3. So we can have the numerator be the derivative of the denominator. So we can use the ln rule. So it will look like this. 3x minus k with limits 3k, k. So then, putting this fully, get ln 3 and 3k minus k, or minus ln 3 times k minus k. And this is the same as writing this as 2 over 3 ln 8k minus ln 2k. This is the same as writing this as 2 over 3 ln 8k over 2k. And this is the same as writing it as 2 over 3 ln 4, since the k's cancel. Then you just write therefore independent of k. That's for part B. Show that integral 2k, k, 2 over 2x minus k squared dx is inversely proportional to k. So 2k, k, 2 over 2x minus k all squared dx. So this can be written as 2 times 2x minus k to negative 2 dx. So if we do that, we'll get, to divide, we'll get minus 2, minus 1, right, son of a bitch. Add to the power, divide by the new power, times by the derivative, or divide by the derivative, sorry, minus, then we times the bracket, and then add 1 to the power, minus 1. Limits 2k and k. This can be written as minus 1 over 2x minus k, with limits 2k, k. This, therefore, is minus 1 over 2 times 2k minus k minus 1 over 2k minus k. So this can be written as minus 1 over 3k minus 1 over k. So we need to make the denominator the same. So we times the right one by 3. So we get minus 1 over 3k minus 3 over 3k. And this is the same as writing 2 over 3k. And since k is on the bottom, therefore inversely proportional. And that's question 7 done. So moving on to question 8. The depth of the water d meters in a harbour on a particular day is modelled by the formula d is equal to 5 plus 2 sine 30t, where t is the number of hours after midnight. The boat enters the harbour at 6:30 AM and takes 2 hours to load. The boat requires a depth of water to be at least 3.8 meters before it can leave the harbour. So for part A, find the depth of the water in the harbour when the boat enters the harbour. So we need to let t equal 6.5, since that's 6 hours and 30 minutes. So the depth is equal to 5 plus 2 sine 30 times 6.5. Put that in your calculator, you'll get 4.48 meters. Part B, Find to the nearest minute the earliest time the boat can leave the harbour. So the depth needs to be at least 3.8 meters. So, and we need to find t. So 3.8 is equal to 5 plus 2 sine 30t. We can subtract 5 and divide 2 from 3.8. That will give you negative 3 over 5 is equal to sine 30t. So do an arc sine of 30t is equal to arc sine of negative 3 over 5. But because it's 30t and we've only got t here, this will be the same as 30t 720. But because we only need to find the earliest time, it won't be that much of an issue. So if we do the arc sine of negative 3 over 5, we'll get negative 36.869. Then 180 minus that answer, 216.869. And then 323.13. So if we divide 30, this one will not fit into the time since it will be negative. Divide 216, you'd get 7.228, which you'd have to reject since it does not enter by at least 8:30, since it's enters at 6:30 and takes 2 hours, and that would only be 7 hours. Then divide this one by 30, you'd get 10.77, which is so therefore t is equal to 10.77. However, we need it in a time, so if you times 0.77 times by 60, you get 46. So then therefore these at 10:46 a.m. and that's question 8 done. So for question 9, part A, we need to show dy by dx is this. However, we can notice that this does not equal 0. It's also not equal to y. So we need to use implicit differentiation. So you do that. So we do x squared, so 2x minus, and so it's 2xy. So we need to use the product rule. So u is equal to 2x, u dash is equal to 2, v is equal to y, v dash is equal to dy by dx. And so when you differentiate y using this rule, you just get dy by dx. So it would then be, sorry, u dash is supposed to be minus 2, u is supposed to be fucking up. Right, yeah. So minus 2y u dash times v, u times v dash, minus 2x dy by dx. Then for 3y squared, be 6y times dy by dx equal to 0. So when you differentiate 50, you get 0. So then you need to bring the dy by dx is on one side. So 2x minus 2y is equal to 2x dy by dx minus 6y dy by dx. If we take out factor out the dy by dx, so 2x minus 2y is equal to dy by dx times 2x, sorry, not d, 6y minus 6y, and then we divide that, so we get dy by dx is equal to 2x minus 2y over 2x minus 6y. We're not done since they want it in y minus x over 3y minus x. So dy by dx is equal to, we divide everything by 2 since you can, x minus y over x minus 3y, and we times everything by minus 1 to get in the form that they want. Y minus x over 3y minus x. And that is part A done. With part B, find the exact coordinates of B. So, since the gradient of a straight up line is technically 1 over 0, so basically we just flip the dy by dx and have it equal 0. Well, flip it, I mean have the denominator as equal to 0. So, part B, x minus 3y is equal to, or 3y minus x, whatever, is equal to 0, so x is equal to 3y. Then, good stationary point, put 3y into the original equation. So we have 3y all squared minus 2 times 3y times y plus 3y squared is equal to 50. So this comes out to 9y squared minus 6y squared plus 3y squared is equal to 50. Simplify, 6y squared is equal to 50. Y squared is equal to 50 over 6. So then y is equal to plus minus root 50 over 6. However, since on the graph this is obviously in the minus area, we need to choose the minus option. So then y is equal to negative root 50 over 6. And so that is the same as, let's put it in your calculator, is equal to minus 5 root 3 over 3. So now we need to find the x. So we just put the x into the 3y, so x is equal to 3y, so x is equal to 3 times this, and we'll get x is equal to minus 5 root 3. So point P is negative 5 root 3 on the x and 5 root 3 over 3 on the y. So part C, explain briefly how you find the coordinates of the point that's furthest north. So part C, basically you'd write set dy by dx is equal to 0 since the tangent there is a straight line like that rather than upwards. And you would solve simultaneously whatever the southern, since there's also the bottom one, and northern points, and then choose the answer with the positive since it's the north. And that is that for question 9. So now moving on to question 10. The height above ground h meters of a passenger on a roller coaster can be modelled by the differential equation. There it is. Where t is the time in seconds from the start of the ride. Given that the passenger is 5 meters above the ground at the start of the ride, show that h is equal to 5 e to the power of 0.1 sine 0.25 t. So we can start by dividing h and times it by dt. So we get all the values onto the same side. So cos 0.25 t over 40 times by dh dt. Right, and yeah, and then it's the integral. So if we do that, we get ln h is equal to would be 1 over 40 times 0.25. I mean, divide. Yeah, 1 over 40 because it's times. Divide by 0.25 since it's the derivative. You get 0.1 sine 0.25 t plus c. Then, if we look at the question, from the start of the ride, passage is 5 meters. So we need to let t equals 0 and h is equal to 5. So then 5 is equal to 0.1 sine 0 plus c. 0.1 sine 0 is 0, so therefore c is equal to 11.5. By the way, I love Ermac way more than she loves me. And then, so we can write it as ln h is equal to 0.1 sine 0.25 t plus ln 5. Then bring the lns to the same side, so ln h minus ln 5 is the same as ln h over 5 is equal to 0.1 sine 0.25 t. If we put everything to the power of e, we get h over 5, since the ln's cancel, equals e to 0.1 sine 0.25 t. Then times 5, we get h is equal to 5e 0.1 sine 0.25 t. And that is done for part A. So part B, state the maximum height of the passenger above the ground. So when there's a max height in this scenario, the sine 0.25 should be equal to 1, since that's the max of a sine graph, right? So then h is equal to 5e to the 0.1 times 1, which put in the calculator is 5.526. So then h is equal to 5.53 meters. It's done for part B. For part C, the passenger reaches the maximum height for the second time, t seconds after the start of the ride. Find the value of t. So since they found it for the second time, we need to find t. Well, it's the maximum height, so we stick with 0.25 t is equal to 1. So we do arc sine, so 0.25 t is equal to the arc sine of 1. So 0.25 t is equal to, and since it doesn't specify degrees or radians, we'll stick to radians. So the arc sine of 1, you'd get pi over 2. However, that is the first one, not the second one, which we want, so we reject. Then, so the second one would be 5 pi over 2. And then we divide by 0.25, we'll get 10 pi. And there's the answer for question 10, and that's all done.